Hello everyone and welcome back to my channel. Today we are going to have a very fun lab with the IP version 6 BGP, IVGP and eBGP. This is going to be a quite easy, smooth and a straightforward lab based on the diagram that you see on my screen now. Um, so what we are going to have is that we have two autonomous systems, AS 1.1 which is on the left, as you can see here, with one router, which we are using 4-octet AS numbers. And also on the right, we have AS234 or 234, which has three BGP speakers. And we have some objectives, and everything will be IP version 6. So before we start jumping to the configuration and we start talking about the objectives, I would like to let you know that what we are going to do with this diagram. So basically, what the objectives want from us, before I read it like let's say officially, but I want you to be on the same page with me, because on the AS234 I have a special kind of physical topology, in order to add more flexibility to my labs and giving ability to me to work with this lab later as well for other scenarios. I have one switch and three connected routers to that LAN segment, but I have sub-interface configured on all the routers connected to this switch too, which allows me to be more flexible, to have peering, and to have different VLAN and LAN segments. So if I want to show you, hold on a second, that what we are going to do on this lab. So we are going to have an eBGP peering between this loopback interface, loopback 1, and this loopback interface, loopback 1, this IP address is between R1 and R2, which is eBGP, is going to be eBGP. And then we are going to have IVGP. I will change the pen color to red. We are going to have IBGP between R2 and R3 over VLAN 23, right? This is a subinterface gig 123, like that. This is going to be IBGP between these two, this loopback, and again this loopback, which are loopback 1, and another IBGP again between this loopback and this loopback between R3 and R4 over VLAN 34. So the LAN segment is like, this is one LAN segment, this is going to be one LAN segment, and this is going to be third LAN segment. So in this scenario, R4 and R2 are not going to be BGP peers directly. And there is a purpose for that, because we would see BGP split horizon in action and how to tackle that. That's one of the coolest parts of this lab scenario. Okay, so according to what I just said, we can have better digestion of what the objectives are. So let's read them quickly. IP version 6 eBGP peer between AS1 and AS234. It means between R1 and R2, as I told you. IP version 6 IBGP peer from R2 to R3 and R3 to R4. So as I told you, between R2 and R3 over VLAN 23, and R3 and R4 over VLAN 34, right? All BGP peering uh, must be between, it must be between loopback 1 to loopback 1, right? This is another one. Advertise loopback 2 from R1, from here, this loopback 2. Advertise loopback 2 from R1 in a way that all BGP speakers with an AS234 receives it. So it means that when we are advertising this particular loopback uh, /64 IP version 6 prefix from R1 to AS number AS234, all the IBGP speakers should be able to receive that, and even R4, which is at the end of this kind of end of the autonomous system 234, should also be able to receive it. And also on the other direction, vice versa, advertise loopback 2 from R4. This is loopback 2, this one, from R4, sorry, in a way that R1 also receives it. So this advertisement of this route, this prefix, should come in this way to R3, and R3 should be able to advertise it to R2, and R2 should be able to advertise it to R1, and we will verify that. So there is another objective that I forgot to add, but I added now, that in case of need of IGP within AS, only Ospf version 3 must be used, right? And in case of need of IGP, only static routes. This one, the first one must be used within, or within AS. Yes, I mentioned that. Only static routes must be used between ASs. Yes, yes. Okay. So what does it mean? It's forcing us that if we are going to have, and we will discuss it why, we are going to have any IGP running in order to provide IP connectivity between the loopback addresses that we would need the BGP to be over that IGP, we have to use OSPF within each AS autonomous systems. But in that case, that we don't have any other router other than R1 in autonomous system 1.1, then we will be only using OSPF v3 within autonomous system 234. And between the two, we have to do everything statically. Okay. So let's jump into right to the configuration. So let's go to our R1 and see what we have. All IP version 6 addresses on the interfaces, I have pre-configured all of them just to save more time. So just be sure and to verify that we have basic IP connectivity between the autonomous systems. I will do show IP version 6 interface brief. As you can see, for gigabit 00, this is the IP address that I have hard coded on that interface, and this is the link local IP address. And I have two loopback interfaces. This loopback interface, all loopback interfaces in my scenario and in my lab scenario, they start with 2002, and physical interfaces, the IP version 6 IP address starts with 2A0A. And the second one, the second section of the IP address is consisted of the two routers IDs. So this means that this link is between gigabit 00 from perspective of router 1 is between router 1 and router 2. And so if I do show run section router, sorry, section router. I just want to make sure that I don't have any pre-configured routing protocol. Okay, nothing. Very good. So if I go to R2 and if I do show IP version 6 interface brief, as you can see, the same. I have the IP version 6 address hard-coded on gigabit 00 and my loopback. And also on my sub interface, as I told you, which this interface 01.23, which enables encapsulation.1q. So just for you guys that you are not familiar, how to configure sub-interface for IPv6, I have to tell you that it's completely similar to what you do for IPv4. So if I do show run interface geek 0/0 no slash 1.23.23, you can see that nothing is special here. IPv6 address is assigned, encapsulation.1q with VLAN ID, and that's it. Okay. So just to be sure, I'm going to show IP version 6 interface brief. I'm going to ping router 1 IP address that I have point-to-point connectivity, which is 1, and I'm able to ping that. So it's ready to go for BGP peering. So let's start the BGP peering. What the objective asks us is that we need BGP peering between the two loopback IP addresses. And as you know, in order to have eBGP peering, regardless of if you're doing an IP version 4 or IP version 6, between two loopback interfaces, between two routers, you need to meet three conditions. First, as you know, the TTL value for eBGP is 255. Sorry, for eBGP is 1. And if we are going to have a loopback connectivity, loopback peering, we need to increase that either by increasing the value of TTL or by executing Cisco best practice command, which is disable connected check. We will see. So that's one of the options. That's one of the conditions that you have to meet. The second condition is that you need to have IP connectivity between the two loopback interfaces. And that comes somehow without saying, because if your router doesn't know how to get to the loopback of the other router, then it cannot establish the TCP session between the two and source the TCP session with that IP address, right? So this is the condition number 2. And for condition number 3, what was condition number 3? So sorry guys, I just forgot because I start uh, I start um, recording these videos without any preparation. So sometimes it just forget topic. So first of all, it was eBGP multi-hop, and it has to have what was the third condition? Anyway, we can see during the configuration. Oh, update source. Okay, I just remembered now. So what does it mean? We have to use update source command, and why is that? Because when you configure BGP peering between two routers from the directly connected interfaces, the BGP packet, TCP BGP packet that has to go from your router, let's say router 1 to router 2, the source IP of the packet will be the interface uh, that you're running the BGP on that, right? That the neighbor is pointed on that. So in order to change that, because that's not going to work, because if the other router receives that, and when the other router has the neighbor statement in his BGP instance pointing to your loopback, then it's going to check that the IP address that was on the source IP address was on the packet he receives, is not matching with the IP address of the neighbor that you have put on the command line. So that's not going to bring up our BGP peering. So we have to tackle that as well, and we will see how. So let's start from router 1 Okay, let me just make it bigger. Router 1, global configuration mode, router BGP 1.1, BGP router ID. I will put it 111, BGP log neighbor change. I just want to have the syslog messages coming up to have the loggings of what's going on with my neighbor changes, right? So here we are going to put the neighbor statement as we do for IPv4. So we do neighbor neighbor. We put the loopback IP address, which was loopback 1 of router 2 here. Remote AS 234. Okay, perfect. Now the second command is that we have to say that update source, as I told you, the last condition. When you create a package, please change the source IP address to my loopback 1. And that's it from the BGP side for now. I will also add one IPv6 route on a static route that in order to get to this IP address, this loopback, based on our objectives, it says that we have to use a static route between the autonomous systems /128. Use the next hop, which is this IP, show IPv6 interface brief, which is this IP, right? On R2. So we have educated our router that in order to get to the loopback, use this IP. Now, one missing thing from the BGP part is that if I go back to router BGP 1.1, and if I do neighbor 2002 column 2 ACAD column CD zeros column 2, and I should say either eBGP multi-hop and I change the TTL, or Cisco best practice disable connected check. Perfect. So if I do show run section BGP, what I see here on my part, let's check. Okay, as you can see, first of all, I put in my configuration router BGP 1.1, which was the dot notation format, and iOS has converted it to AS plain format automatically. We can change it back with the dot notation command to 1.1, but we don't need that. So the last piece of the puzzle from R1 is that everything is configured based inside my BGP instance, but I have to create and activate IPv6 unicast address family in order to have IPv6 address family unicast attribute attached to my NLRI when it's advertised to the other peer. So in order to do that, we go to the global configuration mode, then router BGP 25537 or 1.1, and we do address family IPv6 unicast, and we are inside address family for unicast, and we do neighbor, this neighbor, which is our two loopback IP address, activate. So don't forget that you have to activate IPv6 neighbors manually. So let's see what we do have. Do we have show run section BGP? Okay, so this is the fun. This is the fun part. As you can see, when I created the IPv6 asset address family, there is IPv4 address family instance created automatically, and I didn't put this command, but it created this command inside my IPv4 address family that no neighbor this IP address, which is the loopback of my neighbor, activate, and then instead activate it in IPv6 instance. Okay, so I think we're good to go on R1. We have our neighbor command, we have our update source, we have our disable connected check, and if I do show IPv6 route for this loopback, I should see a route which is static. Okay, everything looks all right on R1. Let's jump into R2 and we have to do the same. So we do router BGP 234 BGP router ID. Oh, sorry, router ID 2222 BGP log neighbor changes neighbor. What was the IP address of the loopback of my friend? It is just like mine, with the difference of here, which is 1, right? And this is also 1. Let me check real quick on R1. Show IPv6 interface brief. Loopback 1. Yes, it's like that. Okay. Neighbor remote AS 1.1. Then update source loopback 1, and also disabled connected check. Everything all right here. Then we will go directly to the address family IPv6 unicast neighbor loopback address of R1 activate. Okay, my BGP peering is not going to come up, and the reason for that is that because my router 2 doesn't know how to get to this loopback, or it does. Wait a second, how it does? Maybe I forgot to remove before starting the lab my static IP. Let's see, show run section IPv, let's say IP route. IPv6 route. Oops. IPv6 route. How this router knows to get to that IP? Show IPv6 route static. Okay, show run. Do I have this static route already here? Oh yeah, I have it. Okay. Uh, Apologies for this, guys, because I had this static route before I start recording. I forgot to remove that. So basically, that was the last piece of the puzzle that I should have done that, which I did on R1, and adding this static route based on the objectives. Uh, just just note that we can also have this route reachability by configuring OSPF or eRGRP between the two routers, but that's very unlikely in production because between the two ASs you don't really use IGP, right? And on the other hand, our objectives also say that you should use between the AS autonomous systems a static route, not IGP. So our IGP is up. Let's do a quick check. Show BGP IP version 6 unicast summary. This is similar to what we see for IP version 4. So this is my neighbor, which is the loopback IP address of the R1. This is the AS number of my neighbor, messages received and sent, table version 1, okay, and zero prefix. I haven't received anything yet, and that's a good sign. So if I do show BGP IP versions unicast, I wouldn't see anything because I haven't received any route. Okay, so my eBGP is up. Let's jump quickly to R2 to configure the iBGP between R2 and R3. We will do a little bit more quickly this part. So the three conditions that we had in order to bring the BGP peering up between the two loopback interfaces for eBGP now are the same for iBGP, with the only difference is that you don't really need the eBGP multi-hop command or disabled connected check command, because by default iBGP packets have TTL value of 255, so that's not going to be a problem. So again, in order to bring up the BGP peering, I need to have reachability, IP reachability to loopback interface behind R3, which is this guy, right? If I copy that, let's see if I have the reachability. Oops, sorry. R2. I'm gonna ping it here. Ping. No valid route for destination. That's a good news. Okay, not the one. Okay, so it means that I don't have reachability for that. So let's configure first OSPF version 3 very quickly. So config IP version 6 router OSPF 1 router ID 2222 log agency exit interface giga 0/0.23 IP OSPF IP IPv6 OSPF process ID 1 area 0. Enabled on this interface. IP is not enabled on this interface. Why is that? Show run interface gig 0 dot. Oh, I made a mistake. Okay. Show IP version 6 interface brief. Okay, show IP interface brief. I created one sub interface which was not necessary. So this was the mistake. I should have put gigabit 0/0/1.23, not that. Okay, let's get rid of that. No gigabit, no interface. Okay, so show IP interface brief. Deleted that down. Status is deleted. Perfect. So show IP version 6 interface brief. What I have deleted down. Perfect. I have 1.3. I should run OSPF version 3 on this interface. So if I do, just to make sure what is going on there, show run interface gig 0/1.23 encapsulation.3. Okay, everything okay. Conf interface gigabit 0 and IP version 6 OSPF process ID area 0. Good. So if I do show IP version 6 OSPF interface brief, it shows that I'm running OSPF only on this interface and the state is wait. That's okay. Now let's configure quickly also OSPF on R3 fonts, just very quick, otherwise I will just increase the size of my font because it's too small for me, and I think it would be better for you guys as well when you wanna watch the video. I will put it as 13. Okay, R1. Okay, this one. Change setting, appearance, change 13. Okay, now on R3, let's first ping R2, which is this IP with last two. Okay, I'm able to ping it. Okay, I'm gonna configure the router IP version 6. Sorry, IP version 6 router OSPF 1 router ID 333. As you can see, it's complaining about router ID because it doesn't have any IP version 4 assigned to interfaces, but I just hardcoded it here. Then log agency changes, exit, interface gig 00/23, IP version 6 OSPF 1, area 0. My agency should come up, and it's up. Perfect. So if I do show IP version 6 OSPF neighbor, I can see that I'm running, I have my neighbor up, and if I do show IP version 6 OSPF interface brief, I'm running on gig 00.23. That's good, but it's not enough because I have to run OSPF on loopback 1 in order to advertise it to R2. So let's do that. Conf show IP version 6 interface brief. Loopback 1, okay. Conf interface loopback 1. IP version 6 OSPF 1 area 0 and passive interface because I don't want advertisements. IP version 6 OSPF passive OSPF 1. Okay, I cannot make it passive here. I have to make it passive inside the instance. Okay, just forgot that. Anyway, so if I go to R2, I should receive the route for R3. Show IP version 6 route OSPF. As you can see, I'm receiving. I have reachability to R3. I have to do the same here. So if I do show IP version 6 OSPF interface brief, it's not running on loopback 1. Conf interface loopback 1, IP version 6 OSPF 1, area 0. Now I'm advertising that to R3 as well. Show IP version 6 route OSPF. And there you go. I can see the advertisement, route advertisement from R2, which is the loopback, and I can ping it. Perfect. So one of my condition is fulfilled in order to have the IBGP running between the two, right? Between R2 and R3. So I will go to R2 and I will start the BGP configuration. Conf t router BGP 234. Let's I just forgot if I have any show run section BGP. If I have any BGP configuration already in place for R2, I don't think so. Yeah, I have it. This one was for peering to R1. Okay, so let's jump into this one. Another neighbor status, another neighbor command, which includes show IP version 6 interface brief. This IP, I'm gonna peer with this guy, this loopback. Oops, wrong place. Here, remote AS 234, which means that it's IBGP, and update source loopback 1, and address family IP version 6 unicast, again neighbor 3 activate. So let's see what we have here. Show run section BGP. Okay, I have my neighbor activate here, and I have 3 remote is 2.3 update source. And as you can see, as I told you, I don't need this command for that because it's not eBGP, it's IBGP. Okay, let's quickly configure R3 as well. R3, just to make sure we don't have any configuration left over from previous lab. Show run section BGP. Nothing. Okay, good. Conf router BGP 234 BGP router ID 333 BGP log neighbor changes neighbor. If I do show IP version 6 route Ospf, then I do neighbor to this guy, which is the loopback on port 2. Remote yes 234 and update source loopback 1, and I think that should do the job, right? Oh no, I have to activate it. Address family IP version 6 IP version 6 unicast, and I have to activate the neighbor. Activate. Okay, we should have our peering up. Let's see if it comes up. And it's up. Perfect. So we have the IBGP peering between R2 and R3 as well. So let's see what we have from perspective R3. We should have just one neighbor. Show BGP IP version 6. Show BGP IP version 6. Unicast summary. Perfect. I have the loopback address of R2 here as my neighbor. And if I go to R2, I do show IP version 6 BGP unique, so IP version 6 BGP unique, show BGP IP version 6 unicast summary. I will have 2 neighbors. So this one, which is the router 1, is eBGP. As you can see, the autonomous system is different than mine. My local AS number is 23. This one is different, it's 65,537, and the router 3 loopback address, which I have peered with, has my own local AS number, which means that it is an IBGP. Okay, so I think that's it for now, and we will continue with bringing up IBGP between router 3 and 4, and also the advertisement for the routes, and see the impact for IBGP split horizon rule in next video. Thank you for watching.